How to show events are independent, example 1. Two events, A and B, are said to be independent if the probability of A happening is not affected by the event B happening. Also, if two events are independent, they would follow this multiplication rule for independent events that says the probability of A and B happening would be equal to the probability of A multiplied by the probability of B. We're going to use this to show if events are independent or not. If two events are not independent, well then event A is affected by event B and it's said to be conditional probability. In a group of 60 students, 20 study history, 24 study French and 8 study both history and French, 24 study neither. We're asked to illustrate this information on a Venn diagram. So we see there are 60 students altogether, so that's the universe. One of the sets would be history. There's 20 in history and there are 24 in French. 8 study both history and French, that's the intersection. 24 study neither. If we take 8 from 20, we see there's 12 studying history only. 8 from 24 is 16 that study French only. So that's our Venn diagram drawn. So now we have to investigate if the events a student studies history and a student studies French are independent. If they are independent, they follow the independent multiplication rule, which says that the probability of history and French should be equal to the probability of history multiplied by the probability of French. So let's see, is this rule true here? So firstly, we see the probability that someone study history. So the fraction of students studying history here would be 20 out of 60 or 1 in 3. The probability that someone studies French, well, the fraction of students that study French are 24 out of 60. And dividing above and below by 4, we see that that's 6 out of 15. So if we multiply the probability of history by the probability of French, it's 1/3 by 6/15, giving us 2/15. The probability that someone studies both history and French, we can see the fraction here is 8 out of 60, which is also 2 out of 15. So we could conclude here that yes, these are independent events because the probability of H multiplied by the probability of F is equal to the probability of H and F. So this is how we might use the multiplication rule for independent events to prove if events are independent or not.